Before we begin, take a moment to get comfortable. Let your arms go heavy, your breath slow. And as you listen, feel free to leave a comment sharing what time it is, where you are, and what city or village you're listening from. It's love to know. And if you'd like more quiet stories like this one, don't forget to subscribe so they gently appear when you need them most. Now, let's begin. The sky is never still. Even when it looks empty, it moves slowly, silently, invisibly, above rooftops and hills, above forests and oceans. A river of air is always flowing, carrying warmth, carrying cold, carrying memory. We call it weather. But weather is not just what we feel on our skin. It is not just wind or rain or heat. It is the planet breathing, and it begins with light. The sun, our nearest star, sends a stream of energy across the void. Some of that energy travels 93 million miles through the vacuum of space and lands softly on Earth's curved surface. But not all places receive this light equally. At the equator, the light arrives straight on, full, warm, direct. The poles, it arrives at a slant, stretched out, softer, weaker. This uneven heating is the first spark. Warm air rises, cold air sinks. It's a simple rule, but it moves everything because the earth is round, spinning and tilted. This warming and cooling sets the atmosphere into motion. It causes air to rise over warm land and descend over cool sea. It causes winds to swirl and shift. It drives the great currents of the sky, and this movement comes weather. Sometimes it begins gently, a breeze lifting the edge of a curtain, a cloud building quietly in a blue sky. Other times it gathers strength. A small instability becomes a thunderstorm. A difference in pressure becomes a cyclone. The air begins to organize, to churn, to spiral. But even the most violent storm began as heat, quietly rising. We live at the bottom of this great ocean of air of the atmosphere. It stretches from the ground to over 300 miles up, though most of what we call weather happens in just the lowest 10 miles. This layer is called the troposphere. It's dense, it's wet, it's alive with change. Here, temperature falls with altitude, moisture gathers, winds are born, clouds form and vanish, rain falls, snow settles, and sunlight breaks through again. It is in the troposphere that we feel the world, but we don't see the air. We see what it touches: a tree bending, a flag rippling, a puddle drying. We notice weather not by looking at the sky, but by how it changes. The ground, the way it turns leaves, the way it silences birds, the way it makes us pause. And beneath all of it, there is something else. Pressure. Atmospheric pressure is the weight of the air above us. It pushes down on everything, on oceans, on rooftops, on skin. At sea level, the pressure is just right. We evolved to breathe under this weight. We don't feel it unless it changes. When pressure falls, it's a signal. The air is rising. A storm may be forming. When pressure rises, the air is sinking. Skies clear, calm returns. You can't see pressure. You can feel it in your ears, in your chest, in the way the wind begins to shift. And yet, weather is not just vertical, it is also horizontal. Winds carry air across continents. They bring dry heat from deserts, moisture from oceans, blasts from the poles. These movements follow patterns called jet streams, trade winds, monsoons, but they are not mechanical. They are alive, responding to heat, to rain, to time of year. Each gust of wind is the result of 1,000 forces. We might say a storm is coming, but the truth is, it is already here, forming, rising, breathing. All it needed was the sun. The sun, it's the air and time. And above us, the river of air continues to move, steady, patient, endless, asterisk. The air is never still for long, even in the quietest places. As it's at dusk, high mountain valleys, still meadows. In the hours before dawns, something is always shifting. Molecules of nitrogen and oxygen are brushing against each other, exchanging energy, exchanging heat. Attaining heat, sometimes it happens so gently that we mistake it for stillness. But weather is always working, even when it doesn't ask to be noticed. What happens in one part of the world does not stay there. The atmosphere is not a collection of isolated systems, but one single restless body. A disturbance over the Indian Ocean can grow into something enormous, a tropical cyclone, gathering strength. As it moves westward, its pressure dropping, its winds beginning to organize, like thoughts becoming intentions. Thousands of miles away, that same system will send ripples through the jet stream, like a fingertip grazing the surface of a still pond. Disturbing patterns half a world away. In this way, a summer storm in one country might be connected to a cold snap in another. Everything is connected through balance and imbalance through energy-seeking rest. And this is where humidity and heat begin to reveal their deeper roles. Heat is energy, but not all heat is felt directly. Some of it is hidden in the vapor we can't see. When water evaporates from lakes, oceans, and even our own skin, it carries energy with it. This energy doesn't vanish, stored in the vapor itself. We call it latent heat. And when that vapor condenses back into liquid inside clouds, on the underside of leaves, in the cool exhale of evening, this hidden energy is released again. This invisible exchange powers much of the weather we experience. Imagine a large cumulus cloud forming. As warm, moist air rises, the water vapor in it begins to cool and condense into droplets. With each tiny condensation, a small amount of heat is released into the air around it. That extra heat causes the surrounding air to rise even faster, pulling more warm air upward from below. The process feeds itself like a quiet engine, growing stronger, lifting higher. Under the right conditions, it can escalate into a thunderstorm. The top of the cloud continues to rise until it hits the tropopause, the boundary between the troposphere and the stratosphere, flattening out like a soft anvil. Inside the cloud, updrafts and downdrafts dance in turbulent loops. Water droplets collide, combine, and grow heavy. And when gravity finally wins, rain begins to fall, sometimes slowly, sometimes all at once. The smell of rain, the soft, earthy scent that reaches us before the first drop lands, is another quiet mechanism of the atmosphere. It's called petrichor. It comes from oils and compounds released by plants and soil during dry periods. When rain approaches, the falling drops disturb those particles, lifting them into the air. Our noses pick up on them before our skin does, a signal from the earth that change is coming. Thunder and lightning are not just dramatic expressions of the storm. They are consequences of separation. Inside towering clouds, water droplets and ice crystals are constantly crashing together, creating friction. This friction builds up electric charge, separating positive and negative particles within the cloud. As the difference in charge grows stronger, nature seeks to equalize it. Lightning is that equalization and instant release of imbalance. The bolt can travel from cloud to cloud, or from cloud to ground. It heats the air around it to temperatures hotter than the surface of the sun, rapidly expanding the air, as we then hear as thunder. Light always arrives before sound, not because thunder is shy, but because sound moves slower through the thick layers of our atmosphere. By the time we hear it, the event has already passed. Wind patterns, too, follow these same quiet forces of push and pull. In the northern hemisphere, winds curved to the right. In the southern, they curved to the left. This isn't a decision made by the wind, it's the result of Earth's rotation. We call this the Coriolis effect, and it influences everything from ocean currents, to the paths of hurricanes. It causes large-scale systems to spiral, Low pressure zones rotate counterclockwise in the north, clockwise in the south. That's why cyclones spin. That's why air never moves in a straight line over long distances. The world is spinning, even when we forget. At the equator, the Coriolis effect is weak, and air tends to rise vertically with great intensity. These rising currents form the intertropical convergence zone, a band of persistent cloud cover and rainfall that migrates with the seasons. It's here that many of the world's tropical storms are born, breathed into existence by sunlight, sea vapor, and the slow, patient spin of the planet. Ocean temperatures play a crucial role in all of this. Warm water acts as fuel for many weather systems. When the surface of the ocean is heated by sunlight, it evaporates faster, sending more moisture into the air. Moisture feeds clouds, intensifies storms, and changes wind patterns. El Niño and La Niña, two alternating phases of Pacific Ocean temperature shifts, can influence global weather for months, even years. In an El Niño year, warm waters spread eastward across the Pacific, altering rainfall patterns in South America, creating droughts in parts of Asia, and reshaping the jet stream over North America. In a La Niña year, the opposite happens. Cooler waters dominate, and weather patterns adjust once again. These aren't quick events. They unfold slowly, like chapters in a book written by ocean and sky. And we, unknowingly, turn the pages. Even in smaller ways, weather is quietly shaping the earth beneath our feet. Rain doesn't just fall and vanish. It carves. Over years, rivers grow deeper, valleys widen, and coastlines shift. Snowfall builds layers that compress into glacial ice. Winds lift tiny grains of sand and move them across deserts, creating ripples, dunes, and patterns that look like frozen music. Fog forms when warm, moist air cools near the ground. It's not rain and it's not cloud, but something in between. A soft veil, a pause in vision. It muffles sound and slows time. Mountain regions, fog is calm, especially in the early morning. It rolls through forests like memory, wrapping tree trunks in silence. We often think of weather as something separate from us, something that happens to us, but in truth, we are part of it. Every breath we exhale contains water vapor that will eventually rejoin the cycle. Every step we take changes heat patterns on the ground. Every building, every field, every road, all of them interact with the atmosphere above. Weather is not distant. It is not other, It is us, and we are it. And tonight, as the air cools outside your window, somewhere a droplet is forming inside a cloud. A gust of wind is turning over the surface of a calm sea. A snowflake is beginning to crystallize in a silent sky. Let it happen. Let the world turn. Unseen and unhurried. Let the wind go where it must. Let the silence deepen. Asterisk, somewhere in the atmosphere. Tonight, far above the sleeping cities and still rivers, an air mass is drifting. It is not rushing. It is not violent. But it carries with it a memory, a temperature, a moisture level, a pressure signature that was formed in a place hundreds of miles away. Maybe it originated over an inland lake where the warm surface water gave it a softness. Maybe it rolled across dry terrain, losing moisture with every dusty hour. Wherever it came from, it is now part of a larger pattern, slow, ancient ballet between cold and warmth, rising and sinking, gathering and dispersing. This is how air masses travel. They are not just pockets of wind, but full-bodied systems. And when one encounters another, the atmosphere responds. At the edge of two different air masses lies a front. These boundaries are not visible to the eye, but they are deeply felt. A cold front pushing into warmer air lifts it suddenly, triggering condensation, building clouds, and often creating storms. The warm air doesn't resist it, simply rises, cools, and begins to transform. The result might be a line of summer thunderstorms, flickering with lightning over the horizon. Or it might be a slow, soaking rain that lasts for hours, drawn from the sky in quiet layers. A warm front, by contrast, moves more gently. It slides over the top of the cooler air ahead of it, like a tide creeping across a flat beach. The clouds that form here are often wispy and high at first cirrus and cirrostratus, then slowly lower and thicken, becoming altostratus and finally nimbostratus as precipitation begins. These transitions are not sudden. They are measured, soft, like the changing mood of a long afternoon. Each type of front tells a different story about the forces behind it. Stationary fronts, where two air masses meet but neither advances, can linger for days, bringing extended periods of cloud and drizzle. Clouded fronts where a fast-moving cold front overtakes a warm one are more complex, often seen in mature, low-pressure systems. They represent the end of a weather cycle, the folding in of old energy, and above all of this, steering these systems like the gentle touch of fingers across a turning globe at the jet streams. These narrow corridors of high-speed wind blow west to east at altitudes of 30,000 feet or more. Their position and strength vary with the seasons. In winter, the contrast between polar and tropical air increases, sharpening the jet stream and pulling it further south. In summer, the contrast is weaker and the stream lifts northward. A seasonal breathing, expanding and retreating. Jet streams are not straight lines. Meander, bending in large waves called Rossby waves. These waves determine where ridges of high pressure will settle and where troughs of low pressure will deepen. A trough might bring a series of storms, while a ridge offers a week of calm. From the ground, it feels like a change in mood. In the sky, it is geometry and energy playing out over continents. Sometimes, the jet stream becomes locked in a certain paterna blocking pattern. When this happens, weather becomes persistent. A heat wave may linger for weeks. Rainfall might stall in one place. Cold air may pool and refuse to move. These events can be subtle or severe, but they always remind us that even the fastest winds can be caught in quiet rhythms, down closer to the surface. Another force quietly shapes the weather. Evaporation. Every body of water, ocean, lake, river, even a single drop on a leaf has the potential to send vapor into the air. But evaporation doesn't just depend on heat. It requires energy, movement, dryness, and exposure. A shallow puddle on a sunny day will vanish faster than a shaded pool. A breeze increases the rate, moving away saturated air and replacing it with drier molecules that can hold more moisture, and what evaporates must eventually return. Precipitation is not only rain, it is also snow, sleet, freezing rain, and hailage, the result of specific conditions in the atmosphere. Snow forms when temperatures are cold from cloud to ground. Sleet forms when snow melts into rain and then refreezes before reaching us. Freezing rain stays liquid until it contacts a cold surface, turning to ice on trees, roads, and wires. Hail is more violent train drops carried upward in strong thunderstorm updrafts, freezing in layers until they fall too heavy to rise again. Each of these forms tells us something about the air it passed through. Weather is also shaped by geography. Mountains, for instance, have a profound impact. When moist air moves toward a mountain range, it rises to climb the terrain. As it rises, it cools and condensation begins. Clouds form. Rain or snow may fall on the windward side. But once the air crosses the peak and descends on the leeward side, it warms again, now drier, depleted of moisture. This creates what's known as a rain shadow. Entire regions owe their climates to this effect. The lush greenery on one side of a mountain range and the dry plains on the other are both results of air moving, lifting, shedding, and falling. Cities to affect weather. Subtly but significantly, the urban heat island effect is well documented. Concrete, asphalt, and steel absorb more heat than vegetation or soil. At night, they release that heat slowly, keeping city temperatures warmer than surrounding countryside. This affects local wind patterns, humidity, and sometimes even cloud formation. The difference might be a few degrees, but in weather, a few degrees can mean the difference between drizzle and snowfall. And underneath all, of this, beneath the heat and wind and vapor, is pressure. Atmospheric pressure is simply the weight of the air above us. We don't often think about it, but it's always there, pressing gently on everything. High pressure zones are areas where air is sinking, compressing, warming, and discouraging cloud formation. The skies are often clear, the winds light, the mood settled. Low pressure zones, by contrast, are where air is rising, expanding, cooling, inviting moisture to condense. These areas are more dynamic, more alive. There, where storms are born, pressure changes can be detected by sensitive instruments, by animals who often react before humans notice. Birds may fly lower, dogs may become restless. Some people feel a heaviness in their joints or a dull ache behind the eyes. These subtle responses are part of a much older awareness, one we've quieted, but never fully lost. Even the human body is a participant in this atmospheric exchange. When pressure drops rapidly, as before a storm, our blood vessels may expand slightly. When humidity rises, our skin feels different, our breathing changes. When the wind shifts, carrying pollen or dust, our senses detect it in ways we may not fully register. Weather moves through us, not just around us. And so, every day, whether we notice or not, we walk beneath a sky that is alive. Not alive like an organism, but alive like a system, responsive, fluid, shaped by memory and energy. A place where sunlight becomes motion, where ice becomes cloud, where invisible forces become the sound of rain on rooftops. Tonight, as the earth turns and the atmosphere flows across its surface, a new front is forming in silence. A fog is thickening in a distant valley, and in the highest layers of the troposphere, wind is turning delicately, decisively toward a different path. Let it turn, let it carry with it whatever needs to move. Let your breath slow to match the rhythm of the wind. Let the pressure fall away. The night deepens, and still the sky shifts above us. Weather does not rest, it only pauses. It slows when the balance is close, when the temperature difference between two places is minimal, when the winds are quiet because they have nowhere urgent to go. But even then, microscopic changes are happening. Molecules vibrating a little faster. It's a pocket of warmer air rising unnoticed over a quiet road. It's a slight dip in pressure that won't be felt until morning. These small adjustments are the early thoughts of larger patterns. Clouds, too, are not still things. They move, they grow, and dissolve. They evolve from one type into another. A cirrus cloud, high, wispy, made of ice, can fall into lower layers of the sky and thicken into altostratus, then deepen into nimbostratus, bringing gentle rain. A solitary cumulus puff can rise into a towering cumulonimbus, heavy with electricity and storm, but it begins as nothing more than moisture and a gentle upward draft. What we see as the shape of a cloud is the boundary between saturated air and unsaturated air. Inside that boundary, droplets hang suspended. They don't fall right away because the upward currents hold them like breath held softly. But when the currents weaken or when the droplets grow too heavy, they begin to descend. That is how rain begins. Not suddenly, but slowly. Like an exhale after a long silence, the types of clouds tell quiet stories about the day. Straightest clouds stretch flat across the sky, like a soft gray sheet. They bring consistent overcast, sometimes drizzle, but rarely drama. Their presence often means stability, a steadying of the atmosphere. Cumulus clouds, on the other hand, are shaped by energy. They rise when warm air pushes upward with confidence. They are the clouds of sunny afternoons, changing moods. Then there are lenticular clouds, lens-shaped, smooth, and hovering over mountain peaks like silent sentinels. They form when stable, moist air flows over a range and creates standing waves. At the crests of those waves, moisture condenses into cloud. They appear still, unmoving, but they are constantly forming and dissipating, their shapes sustained only by perfect balance. And above all these clouds, far above the reach of most storms, there are cirrostratus layer-steamed veils that sometimes create halos around the sun or moon. These halos are not just beautiful phenomena. They are signs of ice crystals in the upper atmosphere, often a subtle herald of an approaching front. Even in the stillest weather, signs like these are speaking. The world beneath responds in its own slow rhythm. Trees sway gently, not just from the force of wind, but as a way to reduce stress on their trunks. Their leaves have evolved shapes that lessen drag. Grasses bend with breezes, not against them. Even soil participates, drying under the heat of the sun, cracking in patterns, absorbing moisture differently depending on its texture and the rainfall it receives. Weather leaves marks, but not always the ones we expect. A dry spell leaves more than dust. It affects the chemistry of the ground, the readiness of seeds to germinate, the behavior of insects in the topsoil. A single night of frost can kill one plant and toughen another. The same weather, falling in the same place, will not treat every living thing the same, and water itself is transformed by the air. Above it, fog over lakes in the early morning forms when the water remains warmer than the air. The heat rises, the moisture lifts, and a low mist forms across the surface. This mist seems fragile, but it is layered built from the difference in temperature, from the stillness of the wind, from the weight of the night that came before. It disappears, not in an instant, but slowly, thinned by sunlight and carried away by the softest breeze. Dew is even gentler. It forms on the ground when surfaces cool overnight, reaching a temperature at which moisture in the air condenses. Like rain or fog, dew is completely quiet. It accumulates in the night and is noticed only at dawning blades of grass, on rooftops, on windowsills. It is weather at its most delicate, but it can also be the difference between life and death for tiny creatures. Some desert insects survive entirely by harvesting dew. Certain flowers open only when dew has formed. The weight of water changes everything, even in the driest deserts, where rainfall might not come for months. Weather is present. Heat by day rises rapidly from the earth. At night, the absence of clouds means no insulation. The warmth escapes, and temperatures plummet. It is common for desert nights to be freezing, not because of incoming cold, but because of outgoing warmth. This is called radiational cooling, a process by which heat escapes directly from the surface into space. When there's nothing in the sky to hold it back, weather doesn't always bring something. Sometimes it takes things away. Winds can be slow and constant, what we call breezes, or they can arrive in pulses and gusts. The Beaufort wind scale developed in the 1800s. It's a system of measuring wind based on observed effects rather than exact speeds. A gentle breeze might be one that rustles leaves. A moderate one sways small branches. A strong breeze lifts dust or loose paper. Even today, these descriptions remain among the most human ways to talk about wind. Not numbers, but what it touches, what it changes. And among the most haunting winds is the K-A-T-A, B-A-T-I-C. These are downslope winds, cold air moving from high ground to lower valleys, often rapidly, pushed by gravity more than pressure. In Antarctica, katabatic winds are some of the strongest on Earth, but they can also occur in milder places, like the Mistral in southern France or the Santa Anas in California. These winds are dry, forceful, and sudden. They clear skies, but bring unease. The pressure shifts. The air dries out, tempers rise. K. And yet, to the sky, it is all just air moving toward balance. Balance that is the heart of weather. Everything is trying to reach equilibrium. Heat moves to where it is lacking. Moisture seeks its saturation point. Wind rushes to fill voids. Even light bends when it meets layers of different temperature process that can create mirages. K. Making distant objects appear to shimmer or rise above the ground. In colder regions, balance takes a different form. Snowflakes are born high in clouds where moisture and cold dance together. Each flake begins as a speck dust, pollen, or salt that attracts water vapor. As the vapor freezes, it forms a crystal. The shape of the crystal depends on temperature and humidity. Some are simple plates. Others grow intricate branches. No two flakes are exactly alike because they are all uniquely special, but because the conditions of their formation are constantly changing, and when millions of these flakes fall together, they reshape the world. Snow insulates the ground, keeping it warmer beneath than above. It reflects sunlight, delaying the warming of spring. It muffles sound, changing the acoustics of a forest or street. Entire ecosystems shift under its arrival. Some animals retreat, others emerge. The silence of snowfall is not the absence of sound, but the soft refusal to echo. It's weather in its most hushed form at higher altitudes. Snow accumulates into glaciers, slow rivers of ice that move under their own weight. These formations are not just frozen water. They are time-stored in layers. Scientists can drill deep into glaciers and read the history of ancient climates in the trapped bubbles of air and dust. Past storms, volcanic eruptions, even human activity from centuries ago, frozen in place. And yet, the glacier still flows, inches per year, relentless, quiet. So much of weather is like that. Not what we see in the moment, but what is happening behind it, beneath it, before and after it. Not the lightning flash, but the layers of imbalance that led to it. Not the snowfall, but the shift in jet stream that brought colder air further south. Not the gust of wind, but the sunlit hillside that warmed unevenly and changed the pressure just enough to begin it. As the atmosphere rests and turns. As the Earth continues its patient orbit, more changes are coming. Perhaps a storm is forming now, somewhere over warm waters. Perhaps a ridge of high pressure is settling over a coastline. Perhaps a new cloud is forming, unnoticed, at the edge of a mountain range. Let it happen. Let it all continue, quietly, beyond the window, while you rest. Let the air find its path. Let the heat rise and fall. Let the world adjust itself in silence. In the middle of the Pacific Ocean, far from land, where the water stretches unbroken in every direction, something invisible begins to change. Not loud, not fast, but steady. Temperatures at the surface rise just a little more than usual. Current slackens, then reverses. Trade winds soften, begins to pile up above the warm water, and eventually the skies shift. What begins here, out in the open silence of the ocean, can touch every continent on Earth in a matter of months. This is the birth of a pattern, a rearrangement of global weather. It is known as El Niño, and it is not a storm, not a cloud, not a specific event. El Niño is a subtle rebalancing, a wide, slow oscillation of ocean temperatures and atmospheric pressure in the equatorial Pacific. Its effects ripple outward like gentle waves on a sleeping pond. It brings rains to some, drought to others. Floods in Peru, dry fields in Indonesia, an unusually quiet hurricane season in the Atlantic, or an unexpectedly powerful one. Each El Niño is different. Some are mild and barely noticed. Others are strong enough to rewrite seasons. They don't start on a schedule. Only when the ocean and sky agree. Their counterpart, La Niña, is the cooling phase, strengthening the trade winds, shifting storms elsewhere, creating another set of echoes. These patterns are part of what scientists call the El Niño's Southern Oscillation, or so a balancing act that can take years to play out. And though we name them and model them and predict them, they are not fully within our grasp. They remind us that weather is never just local. The warmth we feel on the beach in California might be tied to the rainfall over the Philippines. A drought in Australia may begin with a fluctuation of wind thousands of miles away. The atmosphere is one continuous sheet, bent and shaped by its connections. These large-scale connections, known as teleconnections, include more than ENSO, the North Atlantic Oscillation, the Pacific Decadal Oscillation, the Mendelian Oscillation. Each describes patterns, not in individual weather events, but in how entire regions of air pressure and wind flow interact over time. They are the background music beneath the daily forecast, the unseen hands behind what we feel. And in recent decades, the atmosphere has begun to hum a slightly different tune. The Earth is warming. This is not weather. It is climate, and the two are not the same. Weather is what we experience day to day: sunshine, rain, wind, temperature. Climate is the average of all that, stretched over decades. A shift in climate means the ingredients of weather are changing. The recipes are evolving. The extremes become more likely. A hotter baseline means more evaporation, which means more moisture in the air, which means heavier rainfall when it comes, and longer dry spells between. The atmosphere now holds more water vapor than it did 50 years ago. This doesn't mean it rains all the time. It means that when it does rain, it rains harder. Storms feed on this moisture. They grow stronger, draw more energy from the surface, and last longer. Hurricanes intensify more quickly. Heat waves stretch for more days. Cold snaps still occur, but sometimes they are distorted, displaced by a twisting jet stream made unstable by warming. It is not chaos. It is acceleration, and the evidence is not only found in melting glaciers or rising seas. It is also found in earlier springs, in longer pollen seasons, in migrating birds that arrive too soon, before the insects they feed on have hatched, in plants that bloom before the last frost, in river ice that forms later and breaks sooner. Weather is the expression. Climate is the memory that the earth remembers, and it is not just warming, it is also adapting. The atmosphere is not static. It has survived vast changes before: ice ages, volcanic winters, periods of intense heat, but always slowly. What makes this moment different is speed. Few degrees of global change unfolding, not over millennia, but over a single lifetime. And still the clouds drift. Still the winds carry the weight of what is past. High above the clouds, beyond even the jet stream, lies the stratosphere, a layer of the atmosphere that is colder and thinner, but still influential. This is where the ozone layer resides, shielding life from ultraviolet rays. It is where large volcanic eruptions can send aerosols that linger for years, cooling the planet by reflecting sunlight back to space occasionally. Something rare happens here: a sudden stratospheric warming. In the winter months, especially near the poles, the stratosphere can experience a rapid temperature spike, sometimes 30 to 50 degrees Celsius in just a few days. This disrupts the polar vortex, the tight circulation of cold air around the pole. When the vortex weakens, pieces of that cold air can spill southward, bringing deep freezes to places not used to them. What begins in the thin, quiet stratosphere can reshape winter across continents, and this too is part of whether or not just what we feel at the surface, but what is happening in the layers above. The atmosphere is stacked like a subtle cake, with energy and motion flowing vertically as well as horizontally. Thunderstorms stretch upward into the stratosphere. Tropical cyclones pull warm air from the ocean and fling it aloft. Even a forest fire under the right conditions, can create a pyrocumulonimbus cloud, a firestorm that generates its own lightning and sends smoke miles above the ground. Each of these interactions reminds us that weather is not surface level. It has depth, and at the deepest level, at the root of all of it, lies energy. The sun's energy arrives at Earth unevenly, more at the equator, less at the poles. This difference creates all movement in the atmosphere. Air warms and rises near the equator, then flows toward the poles at high altitudes, cools, sinks, and returns, setting up vast circulation cells. The Hadley cell, the Farrell cell, the polar cell. These massive loops shape trade winds, deserts, and storm belts. Deserts, for example, are often found around 30 degrees latitude, north and south, where sinking air from the Hadley cell compresses and dries. It's not that these places never receive moisture, but the large-scale motion of the atmosphere pushes the odds against it. What we call dry is often a matter of probability, not permanence, and sometimes that probability is broken by surprise. A rogue storm, an atmospheric river, a dust storm that turns the sky red. These are reminders that while patterns guide the weather, they do not command it. There is always room for anomaly. Atmospheric rivers are narrow corridors of concentrated moisture, like long plumes stretching from the tropics into the mid-latitudes. When they make landfall, especially on mountainous coasts, they can unleash enormous amounts of rainfall. One such system can carry more water than the Mississippi River, and yet they are not chaotic. They form with structure, move with purpose, and fade when their fuel is gone. Even dust, seemingly the enemy of clarity, plays a role every year. Sand from the Sahara is lifted by strong winds and carried across the Atlantic. Some of it settles in the Caribbean, some in South America. It fertilizes the Amazon rainforest. It dims the sky. It reduces hurricane formation by stabilizing the atmosphere. It is part of the balanced particles from one continent shaping life on another. And this is what weather ultimately is: exchange, heat exchanged for motion, moisture exchanged for form, pressure exchanged for peace. The atmosphere is a constant negotiation between what is and what could be, between the memory of yesterday and the possibility of tomorrow. Even the moon plays its part. It tugs not only on the oceans, creating tides, but subtly on the atmosphere, creating atmospheric tides. Daily oscillations and pressure that follow the lunar rhythm. Their effect is small, almost imperceptible, but they exist, okay? And in a system as delicate as weather, even the smallest forces matter. Tonight, the air outside may feel still, but it is not. It is turning. It is stretching. It is responding to patterns older than any of us, patterns written in sunlight, in gravity, okay, and the tilt of the earth itself. You don't need to understand it all. You don't need to follow, okay? Every word. Just let the thought drift past you like a cirrus cloud fading into evening dot. Let the science become silence. Let the weather continue patiently beyond the walls of your room. The air that surrounds us is heavier than it feels. We rarely think of its weight, and yet a column of air stretches above every point on Earth, hundreds of kilometers deep, pressing downward with quiet insistence. This pressure, what we call atmospheric pressure, is one of the most gentle but powerful forces in weather. It does not announce itself with thunder or lightning. It moves invisibly, shifting slowly, influencing everything. Where pressure is high, the air is denser, descending slowly, stabilizing the skies. Clouds struggle to form, winds calm. The days are often sunny, the nights clear and cool. High pressure is like a hand smoothing out the atmosphere, settling things down, pressing away the disturbances. Where pressure is low, the air is rising, expanding, cooling. Moisture condenses, clouds build, winds strengthen. Low pressure is what invites motion. It's the gathering point for storms, the swirl of cyclones, the breath before rain. But it too begins subtly, a dip in readings, a change in direction. A slight drop on the barometer left unnoticed on a quiet kitchen shelf. Barometers were once revered objects kept in polished wood cases. Consulted like oracles, they didn't show weather as much as they hinted at what might come. A sudden fall could mean an approaching storm. A slow, steady rise brought reassurance. Even now, in the age of satellites and supercomputers, that simple pressure reading still holds meaning. It tells us where air wants to go, because air is always moving from high pressure to low, seeking equilibrium. This flow creates wind, and wind, though often described by its speed, has many shapes. There are surface winds, sculpted by terrain, funneling through valleys, curling around buildings. There are trade winds, steady and persistent, that have moved ships across oceans for centuries. There are jet streams, narrow bands of high-speed wind, thousands of feet above ground, circling the globe, cuting weather systems like invisible rivers in the sky. Jet streams form where warm and cold air masses meet. The strongest ones lie near the tropopause, the boundary between the troposphere and stratosphere. In the northern hemisphere, the polar jet stream is the most influential. It wobbles and meanders, dragging storms along with it. When it dips south, cold air can spill into temperate zones. When it retreats north, heat builds and lingers. In recent years, the jet stream has begun to behave more erratically. It lingers in place longer, bending into deeper curves. Some scientists believe this is linked to the warming Arctic. As the temperature difference between poles and equator shrinks, the jet stream loses its tightness. It stretches out like an unraveling thread. This means longer droughts, longer floods, longer heat waves, weather that lingers rather than passes. And still, we go about our days beneath it, beneath clouds that form and fade, beneath breezes that carry seeds and scents. We step outside and feel something, a chill, a softness, a weight in the air, but often can't name it. That's because weather is not just physical, it's also emotional. It shapes our mood, our memory. The smell of rain on dry pavement, the way fog transforms a familiar street, the golden light just before a storm breaks. There's a word for the scent of rain on dry earth, petrichor. It comes from the oils released by plants during dry periods, absorbed into the soil, and then carried into the air by the first drops of rain. It is not the rain itself we smell, but what the rain awakens. It's a quiet release, a memory triggered. And then there are the winds that feel personal. A coastal breeze at dusk, a gust through a half-open window, a warm wind before sunrise, carrying the breath of a coming front. In some cultures, these winds have names, each with its own character. The Sirocco, from the Sahara, dry and hot. The Mistral, cold and fierce, rushing down from the Alps. The Chinook, warm and drying, known as the snow eater in the Rocky Mountains. These winds are not just meteorological, they are woven into stories, customs, superstitions. Some believed certain winds carried illness. Others believed they brought clarity of thought. Weather has always been a conversation between Earth and its inhabitants. Long before satellites, people read the sky. They watched the movement of birds' low flights before rain. They studied halos around the moon, signs of moisture in high clouds. They listened to the stillness of dawn in an atmosphere holding its breath. In Polynesia, skilled navigators once read the sea's surface to detect distant storms long before they arrived. The Arctic Inuit hunters could interpret the softest shifts in snow texture to know if a blizzard was forming. In the Andes, farmers still use patterns of cloud shadows and plant behavior to time their crops. Even animals feel the changes before we do. Bees become restless, cows lie down, dogs pace cases before thunder. Some of this is due to pressure, some due to scent, some due to frequencies we cannot hear. but all of it is real. Weather is not a secret hit. It's simply something most of us have forgotten how to read. And perhaps that's why modern forecasting feels both miraculous and disconnected. Today, thousands of sensors around the globe, from the ground to orbiting satellites, collect data in real time. They measure temperature, humidity, wind speed, cloud cover, solar radiation, and more. Supercomputers ingest this data, simulate the atmosphere, using physical equations, and project it forward, hour by hour, day by day. These forecasts are remarkably accurate. A 3-day forecast today is as reliable as a 1-day forecast was just a few decades ago. But even so, weather resists total prediction. Small error in initial conditions can lead to wide divergence in outcomes. This is the heart of chaos theory, sometimes described by the butterfly effect. A butterfly flaps its wings in Brazil, and weeks later, a tornado forms in Texas. This doesn't mean weather is random. It means it is sensitive, deeply sensitive, so forecasters hedge with probabilities. A 40% chance of rain, a 70% likelihood of fog. They are not unsure, they are honest, okay? They are working with a system where certainty is rare, okay? But understanding is always growing, and in that growing understanding, we begin to appreciate the quieter elements of weather. The boundary layers, thin regions near the ground where the air behaves differently. The role of snow cover in reflecting sunlight. The effect of urban heat islands where concrete traps. Warmth altering local climates. The slow buildup of heat in oceans, storing energy for seasons to come. The role of forests in cycling moisture into the air, creating their own weather over time. And in all of this, the atmosphere is not just a backdrop. It is a living, breathing system. It expands during the day and contracts at night. It pulses with tides and waves and oscillations. It sings in its own frequencies, some detectable, some still mysterious. Even lightning, that most dramatic burst, is still not fully understood. We know it forms when charge builds in clouds, when particles collide and separate, when an imbalance seeks resolution. But why lightning takes the path it does, why it sometimes forks or dances or stays within the cloud, these are questions that remain open. We see the flash, we hear the thunder, but the full map of its choice is still being drawn. And so, even now, in this age of precision, weather remains partially unknowable. It is not a flaw. It is a feature. The atmosphere invites observation, not domination. It wants to be watched, not controlled, to feel the shift in air before rain, to notice the way the light changes just before a cold front, to pause when the wind stills, just before something begins. These are the ways we remain connected. These are the things we knew before instruments told us. These are the gifts, weather gives not just to the earth, but to the ones who live quietly upon it. Let it continue. Let the clouds move where they will. Let the sun rise behind them, the rain fall gently below. Let the atmosphere do what it was made to wrap the earth. In motion, in moisture, in warmth, in wonder. And let yourself rest beneath it all. Let your thoughts thin like mist. Let your breath slow like a settling breeze. Let the sky hold you for a little while longer. Above the noise of cities, beyond the reach of skyscrapers and air traffic, lies the highest part of our weather system, the mesosphere, the thermosphere, and finally, the exosphere, where atmosphere fades into space. Few people think of these layers when they think of weather. They seem too distant, too ethereal. But even here, where air is so thin it barely counts as air at all, the Earth's atmosphere continues to move, pulse, and respond to forces below. Solar storms, huge bursts of radiation from the sun can trigger, glowing auroras in the thermosphere, where charged particles collide with atoms of oxygen and nitrogen. Though these celestial lights seem like pure wonder, they're born from interactions between the Earth's magnetic field and the invisible reaches of weather above. In fact, space weather is a real and measurable force. It doesn't bring rain or a wind in the traditional sense, but it can interfere with radio signals, GPS navigation, even power grids on the ground. Our weather is nested within larger systems Earth's magnetic shield. Solar radiation patterns, gravitational tugs from the moon, and each contributes in ways both visible and hidden, yet even far below. Down where we live and breathe, we see the consequences of this layered complexity in small, human ways. Take morning dew. Dew forms when the surface of the earth grass leaves rooftop schools overnight by radiating heat into the open sky. The air is still and humid, and the surface cools below the dew point. Moisture condenses into tiny droplets. It is not rain. It does not fall. It simply appears. The silent result of a night's conversation between warmth and air. This is microclimate at work weather on the smallest scale in cities. Concrete and asphalt absorb heat during the day and release it slowly at night. Raises the temperature of urban areas by several degrees compared to surrounding countryside. The result is called the urban heat island effect. It changes how air moves, how rain falls, even how vegetation grows. A single tree planted in the right place can lower local temperatures, redirect wind, and increase humidity, weather responds to details. In forests, for example, the canopy holds moisture. It filters sunlight, cools the air, and breathes out water vapor through transpiration. This can lead to cloud formation directly above the treetops. Entire weather systems can be softened, redirected, or amplified by forests. When forests are removed, not only does the carbon balance shift, but so does the hydrological cycle of the path that water takes from sky to soil to river to ocean. The water cycle is, in many ways, the beating heart of all weather. Water evaporates from oceans, lakes, and soil. It rises, cools, condenses into clouds, and falls as rain or snow. Then it flows through rivers or returns underground, eventually making its way back to the sea. But this cycle is not a simple loop. It has detours. Water can pause in glaciers for centuries. It can be trapped in aquifers below the ground for thousands of years. It can sit in a leaf for minutes or in the atmosphere for days. Each pause, each route creates new conditions. When snow falls and settles, it reflects sunlight, cooling the surface and preserving cold. This is known as the albedo effect. White surfaces reflect more energy than dark ones. That's why snow-covered regions stay cold longer. But as snow and ice diminish, especially in the Arctic darker land, and water are exposed, absorbing more heat, accelerating, melting in a feedback loop. These feedbacks are essential to understanding how weather and climate interact. Clouds, for instance, are both insulators and reflectors. Low, thick clouds block sunlight and cool the Earth's surface. Thin clouds trap outgoing heat and warm the surface. The balance between these effects depends on the type, altitude, and extent of cloud cover. And that balance is fragile. 1. Shift in temperature can change which clouds form, where they travel, how long they last. Clouds are not passive. They are sculptors of energy. They determine how much sunlight reaches the ground. They decide where rain will fall. They shade some crops and flood others. And yet, despite their importance, clouds remain one of the greatest uncertainties in climate prediction. We can model ocean currents and ice sheets with growing accuracy. But cloud behavior, how it changes in a warmer world, is still difficult to forecast. Perhaps that is fitting. Clouds have always belonged to a kind of poetry. They drift, they grow, they vanish. They are sculptures of time, and not all precipitation is rain. Snow forms when temperatures within clouds are below freezing. And there's enough moisture for ice crystals to grow. These crystals collect, forming flakes with stunning complexity to to exactly alike, though all follow principles of symmetry and branching. Snowflakes fall slowly, each one shaped by the path it takes through varying layers of temperature and humidity. Some melt before reaching the ground, some combine with others, some glide untouched to earth, covering the land in silence. There's also a sleet train that freezes as it falls, freezing rain liquid that freezes on contact with cold surfaces, hail formed in powerful updrafts within thunderstorms, layered like onions, tossed repeatedly before falling. Each of these depends not just on temperature, but on the vertical structure of the atmosphere. A column of air may be warm at the surface, cold aloft, or vice versa. These subtle gradients determine whether we walk through slush or stumble on ice, and when air rises rapidly, thunderstorms form. They begin with instability, warm, moist air. At the surface, cool air above. As air rises, it cools and condenses, releasing latent heat, which fuels further ascent. Updrafts strengthen. Downdrafts pull rain and hail downward. Lightning cracks through the clouder. Sudden equalizing of charge between regions of air. Thunder follows. Rolling compression of air expanding at supersonic speed. Sometimes these storms rotate, forming supercells, the breeding grounds for tornadoes. Tornadoes are among the most intense, localized weather events on Earth. Born from wind shear differences in wind speed and direction at different altitudes, they can form rapidly, spin with devastating power, and dissipate just as quickly. Some are mere whispers, others tear through towns, lifting houses, uprooting roads, and yet they remain elusive, even with radar, even with storm chasers and atmospheric probes. Predicting exactly where and when a tornado will touch down is difficult. That's because weather exists on a continuum between the known and the unknowable. We measure, we model, we map, but we cannot control. We are always interpreting, never commanding. And while modern life has buffered us from the rawest elements walls, roofs, climate control, we remain, at our core, creatures of weather. Our skin registers humidity. Our joints ache before rain. Our moods shift with light and cloud. Children sleep differently on stormy nights. Old farmers wake before sunrise because they feel a change in the air. Even in cities, where weather seems distant, filtered through windows and apps, it remains present. It leaks in through cracks, waits outside the door. It shapes our stories. It always has. For thousands of years, we have named storms, celebrated the return of sun, feared the thunder, danced for rain, burned offerings to the sky, tracked the seasons with stones and stars, designed calendars from solstices and equinoxes. We have lived in dialogue with the sky, and now, as we understand more, the wonder only deepens, because knowing the names of clouds does not make them less beautiful. Knowing the mechanics of wind does not steal its mystery. The more we learn, the more we see that we are part of this system, that we breathe the same air, that once moved through ancient forests and across ice age plains, that the molecules in a single gust of wind may have once passed over oceans, deserts, cities, and farms, that we are always surrounded by motion, even in stillness. So tonight, let that thought rest with you. Let the atmosphere hold it steady, wait above you. Let your breath slow, let your eyes soften. Let the wind outside, the window become background. Let it all continue without you needing to notice. The sky, even at its most still, is never truly at rest. Above your roof, above the highest trees, above the slow-turning satellites and the shrinking curve of the Earth's horizon, the atmosphere continues to rise layer after layer until it ceases to be air and becomes something else entirely, a transition, not a wall. There is no hard boundary where weather ends, only thinning, dimming, spreading out. But far beneath that invisible ceiling, where most of life unfolds, there are places where air behaves differently. Coastal zones, mountain ridges, valleys, and plateaus. Each of them reshapes the atmosphere in subtle and sometimes dramatic ways. Here, weather is sculpted by the land itself. Take a valley in early morning. As night falls, the land radiates heat back into the sky. But the dense, cold air near mountaintops doesn't stay put. It begins to flow downward, slipping like a silent river into the basin below. This is called a katabatic wind, a gravity-driven current of cold air. In narrow valleys, it can chill the soil more rapidly than expected, frosting crops before sunrise. By morning, the valley may be blanketed in fog, a visible reminder of air's motion, soft and settling. Then the sun climbs. Warm air begins to rise along the slopes, sanabatic wind. The fog thins, birds begin to stir, and what was hidden becomes visible again. In these rhythms, day after day, weather breathes through the body of the earth. In coastal regions, the daily dance between land and sea creates its own weather engine. Land heats faster than water during the day. The warm air above the land rises, and cooler ocean air rushes in to replace it. This is the sea breeze, carrying moisture, sometimes thickening into coastal clouds that roll inland like a tide. At night, the land cools faster than the sea. Direction reverses. Now the breeze flows from shore to sea. It's a gentle exhale. These cycles, though modest, shape entire climates. Some coastal cities are defined by fog. San Francisco, Lima, Cape Town, not because they are rainy, but because they are cool and damp, where moist air meets cold water and condenses into low, persistent clouds. And in places where ocean currents shift the very baseline of climate, the impact becomes global. The El Niño Southern Oscillation, or ENSO, is one of the most influential climate systems on Earth. In normal years, trade winds blow warm surface waters westward across the Pacific, allowing cold water to upwell along South America's coast. But in El Niño years, these winds weaken. Warm water pools in the eastern Pacific. Rain patterns shift. Droughts strike Australia. Floods hit Peru. Storm tracks reorient. These events ripple outward, affecting weather thousands of miles away, because the atmosphere, though local in its effects, is global in its reach. What happens over one ocean changes pressure systems elsewhere. What happens in one hemisphere echoes in the other. And just as oceans drive large-scale weather patterns, so too does land, especially when it lies high. Mountains force air to rise. When wind blows against a mountain slope, the air climbs. It cools as it rises. Moisture condenses. Clouds form. Rain or snow falls often on the windward side. This is known as orographic precipitation. It's on the other side. The descending air is dry, warm, and clear. This is the rain shadow. Some of the driest places on Earth, like the Atacama Desert, exist in the shadow of mountains that steal the sky's moisture before it can pass. And yet, even deserts are part of the water cycle. Infrequent rains trigger bursts of life's dormant seeds sprouting into bloom. Insects emerging in coordinated waves. Birds appearing where the sky seemed empty. These brief spells of abundance are guided entirely by weather. It may not rain for years, but when it does, everything remembers what to do. Desert weather, though sparse, is deeply rhythmic. Hot days, rapid cooling at night. Wind patterns shaped by dry heat. Dust devils, miniature vortices spun up by temperature. Contrasts. The desert has its own weather language, one that moves slowly but not silently and in the cold. High latitudes near the poles, weather behaves with a different tempo altogether. Here, sunlight arrives at a slant, barely warming the surface. In winter, the sun may not rise for months. Snow and ice dominate the landscape. And yet, even in this frozen quiet, the atmosphere remains active. Blizzards sweep across the tundra, carrying ice crystals so fine they feel like sand. Katabatic Winds pour off ice sheets with surprising force, and in summer, when the sun returns, meltwater flows in sudden torrents, reshaping the land. The polar regions also act as mirrors reflecting solar radiation, regulating global temperatures. As these regions warm faster than the rest of the planet, their role in the global system becomes even more crucial. Sea ice melts, permafrost thaws, carbon is released. Feedback loops accelerate. Still, for now, the polar skies remain among the clearest and most humbling in the high Arctic. Under a sky that does not set for weeks, you can watch cloud bands form in perfect silence. You can feel a stillness that is not the absence of weather, but its slowest form. And throughout the world, wherever people live, weather is not just external, it's deeply internal. It defines the seasons. It tells us when to plant, when to harvest, when to gather, when to seek shelter. Even now, with apps and forecasts, many still rely on old signals. The timing of cherry blossoms in Kyoto, the blooming of almond trees in Iran, the first call of frogs after rain in New Guinea. These signs are weather speaking through life and the seasons. Though shaped by Earth's orbit, are translated through atmosphere. Spring is not just longer light, it's warmer air, shifting patterns, the first soft rains. Summer is not just heat, it's rising humidity, longer thermals, thunder in the distance. Autumn carries cooling breezes, lower sun angles, sharper shadows, and winter is stillness, a holding of breath, a gathering of frost. Each season has its own textures of air, its own palette of clouds, its own tempo of wind and silence. And as the climate changes, so too do these rhythms. Winters grow shorter in some places, wetter in others. Summers extend their grasp, storms become stronger, slower, wetter. Floods that once came once a century, now come once a decade. Heat waves break records, not every year, but every month. But amid these changes, the atmosphere still speaks in patterns, still tries to balance energy, still spins, breathes, lifts, and releases. It does not judge. It simply moves. And as observers, humans who live beneath this vast and tender ceiling, we are invited to listen, to notice, to adapt, not to master the sky, but to remember that we belong to it. The air you inhale tonight has passed through billions of lungs before yours. The moisture on your window was once part of glaciers, oceans, clouds, sweat, breath, and mist. The warmth on your skin was energy born in the heart of the sun, traveling for 8 minutes across space before finding you. You are always in contact with the sky, always part of its slow conversation. So let your body settle into that thought. Let your breath follow the rhythm of the wind, slow in, slow out. Let your mind drift like clouds above familiar landscapes. Let go of the need to track every gust or front. Just rest. You are safe beneath a dome of swirling air. The weather is still working, even now, even here, even as you fall gently into sleep. And while the atmosphere moves on without waiting for us, we, in turn, continue to shape it quietly, constantly. The weather we experience each day, warmth on our skin, chill in the air, droplets on glasses, a momentary reflection of a vast, ancient process. But increasingly, it is also a mirror of ourselves. For centuries, weather was something humans observed but did not alter. We watched the sky for signs, listened to the wind, interpreted the silence before a storm. But now, the balance has shifted. Through combustion, land use, industry, and habit, we are adding invisible particles to the air, gases that trap heat, gases that change the very rhythm of the sky. The most well-known is carbon dioxide, or C, released when we burn fossil fuels like coal, oil, and natural gas. Though invisible, it stays in the atmosphere for hundreds of years, absorbing and re-emitting infrared radiation. This shifts the Earth's energy balance, warming the surface over time, CO is not alone. Methane from landfills, livestock, and rice paddies is shorter lived but far more potent. Nitrous oxide from fertilizers and combustion also contributes, alongside industrial gases with complex names but lasting effects. Together, they change how much energy enters and leaves our system. This isn't weather in the moment, it's climate. The long-term patterns that govern weather's tendencies. Climate defines the stage. Weather plays the scenes, and now the script is shifting. We are seeing more extreme precipitation events, heavier downpours, even in places where total annual rainfall hasn't changed. This is because warmer air can hold more moisture. For every degree Celsius of warming, the atmosphere can hold about 7% more water vapor. When conditions trigger rain, there's simply more to release. Storms are not just more frequent in some areas, they are slower, more intense, more disruptive. In the western United States, wildfires now create their own weather. As flames rise, they generate towering clouds of smoke and heat, pyrocumulonimbus. These clouds can produce lightning, which starts new fires. In some cases, they even spin into fire worlds or flame-fed vortices, dangerous, mesmerizing, and entirely natural responses to human conditions. In the Arctic, melting permafrost releases trapped methane, accelerating warming. On tropical coastlines, cyclones reach higher categories faster, fueled by warmer seas. And yet, amid all this, daily weather continues its soft routines. Morning mist still clings to trees. Wind still rolls across wheat fields. Raindrops still ripple across puddles. Because weather is both timeless and immediate. We feel it in our bones, even as its causes stretch across continents and decades. The question then becomes, how do we live within this changing system? How do we understand weather as not just background, but dialogue? One way is to listen more carefully, not just to forecasts, but to patterns, the return of certain birds, the absence of others, the way rain smells, differently in summer than in spring, the sudden stillness before snowfall, the crackle of ice forming on standing water. Our ancestors knew these things before satellites and sensors. They watched the sky with a kind of attention we now reserve for screens. They named clouds, gave meaning to winds, built myths around thunder. And though our tools have changed, experience remains the same. Even now, weather is one of the few things that touches every life, every day. It is the universal presence. Whether you are walking to school, harvesting rice, watching ships leave harbor, or lying in bed near an open window, it is always there, wrapping itself around you, entering your breath, brushing your skin. Sometimes it is loud, lightning, floods, windstorms. Sometimes it is impossibly gentle, a slow drift of snow, the hush of fog. And sometimes this absentor seems to be a string of perfect days, unmoving air. But even then, sky is never still. High above, the jet stream is carving arcs across hemispheres, narrow bands of fast-moving air that steer weather systems around the globe. These rivers of wind form where cold and warm air masses meet, and their position influences everything from where storms land to how long they stay. When the jet stream is strong and straight, weather moves quickly. Systems pass over in a day or two. But when it slows or wavers, systems can stall. Rain lingers over one place, causing floods. Heat domes settle, trapping warmth. Cold snaps dive southward, catching cities unprepared. These changes affect food, water, power, health, but they also affect memory. Ask someone about the weather, and they may recall not just conditions, but emotions. The rainy day a child was born, the snowstorm before a wedding, the heat wave that made nights feel endless. Weather writes itself into our stories. It becomes part of the architecture of memory, and in this way, it connects us not only to each other, but to every human who has ever looked at the sky. Thousands of years ago, people stood on mountaintops to watch for signs of rain. They studied animal migrations. They smelled the earth. They listened. And now, in our modern lives, surrounded by sensors and data, we are still learning how to listen again, how to interpret the wind, how to feel pressure shift, how to recognize the language of clouds. Clouds, after all, are the visible poetry of the sky. They form when water vapor condenses around tiny particle salt, dust, smoke. These particles are called cloud condensation nuclei. Without them, moisture might never form droplets large enough to fall, even in the bluest sky. Particles are there waiting, rising, suspended, and as they rise and condense, the type of cloud depends on altitude, temperature, moisture, content. Cirrus clouds, high, thin, icy threads, cumulus-cott-ony, sunlit, buoyant, stratus-low, flat, misty sheets, cumulonimbus, towering, electric, born of heat and motion. Each one tells a different story, and in their shifting shapes, we find something familiar, ephemeral, ever-changing, just like thought. Sometimes we look up and see a horse, a face, a castle. Other times we see only the sky. That's part of the magic. Clouds invite interpretation. They exist between science and imagination. You can model them, and you can dream about them. Both are true. And when they clear, what remains? Starlight, the cooling breath of night, and that faint sense that above all this motion beyond clouds, winds, layers, and storms, there is a vastness that holds us, that no matter how much we measure and predict, whether still retains a kind of mystery. It is not just air and water. It is memory. It is rhythm. It is the oldest thing we share. The more we understand weather, the more we understand our place within it, not as separate observers, but as participants in a long, quiet conversation between earth and sky. And among the most revealing elements of this dialogue are the smallest. One of the things we do not usually notice is the faint rustle of leaves signaling wind before it arrives. It's a sudden quieting of birds before a storm. The way light softens in the final minutes before rain. These are clues left for those who are willing to feel rather than only analyze. But we also have the tools of science, clear, structured, repeatable tools that help us peer into the workings of the sky: thermometers, barometers, anemometers, radiosondes drifting up with balloons, measuring layers of air as they ascend, satellites that orbit far above, watching entire continents in a single frame, Doppler radar systems that detect the twist of tornadoes before they fully form. And yet, for all this observation, prediction remains delicate. Its forecast is not a promise, it is a probability. The complexity of the atmosphere makes long-range forecasting one of the hardest challenges in science. A single cloud's behavior depends on so many variables: moisture, heat, particles, surface temperatures, surrounding air currents, and those are only the ones we can measure. That's why forecasts improve dramatically for short time frames. We're very good at predicting what tomorrow's temperature will be. Less so when asked about next week, because weather, like water, responds to every surface it touches. Even cities change the weather around them. Skyscrapers alter wind patterns. Concrete holds heat longer than forests. Air conditioning units release warmth back into the surrounding air. This effect is known as the urban heat. It's an island phenomenon where urban areas are significantly warmer than surrounding countryside, especially at night. In summer, this extra heat can increase electricity use, strain power grids, and intensify health risks for those without cooling. But even beyond temperature, cities affect clouds. The heat and pollution rising from dense areas can create localized updrafts, encouraging cloud formation and even triggering rain. In this way, Cities become their own miniature weather systems, and still, weather remembers the old shapes of the land. Beneath highways and buildings, the original contours of hills and valleys still influence airflow. Rivers that have been redirected still leave behind moisture channels. The atmosphere doesn't forget in rural regions. This memory is even more apparent. A small pond changes the temperature of air above it. A forest canopy traps humidity. A stretch of tilled soil absorbs and reflects light differently than a grass-covered field. All of these details shape the weather just above the ground, and just above that, the layers continue to build. The boundary layer, the lowest part of the atmospheres, where weather feels most alive. It is here that air exchanges energy with the surface, here that turbulence forms, here that morning fog rises, and dew evaporates. Above this layer lies the free atmosphere, less turbulent, more uniform, home to the large-scale movements of weather systems, and higher still. We enter the stratosphere where the air is thin, where the ozone layer absorbs ultraviolet light, where clouds are rare but not absent. Occasionally, during intense volcanic eruptions or massive storms, moisture and particles are injected into the stratosphere. These can circle the globe, creating colorful sunrises and sunsets for weeks. Higher still, the mesosphere realm of meteors and noctilucent clouds. Then the thermosphere where auroras dance and satellite orbits begin. And beyond that, space. But all of it happens in just the lowest slice, the troposphere. A thin shell, only about 7 to 12 miles deep, depending on location and season. Everything we feel, see, and breathe, every storm, breeze, snowfall, or heat waves in this fragile film of air. It is astonishing, really, how small this layer is, and how much depends on it. If the Earth were a globe the size of a classroom model, the troposphere would be thinner than a layer of paint on its surface. And yet, within that paint lies every cloud, every gust, every drop of rain you've ever felt. Sometimes, its thinness is most visible during a flight. As the plane climbs, the atmosphere begins to fade. The blue darkens. The clouds fall beneath you. The turbulence ends. You enter the calmer layers above most of the weather. Looking out, you see the tops of thunderstorms, the ripple of jet streams, the curling edges of distant systems. From here, weather looks like geographical landscapes drawn in vapor, but return to the ground. And the experience is very different. On a warm summer day, a child might lie in the grass and watch cumulus clouds form and dissolve, each one a floating sculpture. The heat of the sun lifts air upward, moisture condenses, and the sky becomes a living thing in winter. That same child might press their face to a cold window pane and watch snowflakes drift downward, each one a tiny miracle of symmetry. Number 2 exactly alike, shaped by temperature, humidity, and time. It's what began as vapor has become structure. The transformation of water into weather is among the most beautiful processes on Earth. Evaporation, condensation, precipitation, infiltration, runoff. These are not just textbook terms. They are movements of energy, moments of transition. Water evaporates from oceans and rivers, from leaves and soil and skin. It rises into the air, invisible. It moves, drifts, collects, finds other molecules and condenses. It falls as rain, snow, sleet, or hail. It soaks into the ground or flows over it, eventually returning to its source, and then it begins again. Each time you see a cloud, you are witnessing that cycle mid-motion, a temporary chapter in an endless loop, story with no beginning and no end. But sometimes, weather surprises us not just with intensity, but with stillness. There is a kind of weather that is almost imperceptible, A day when the air is exactly the same temperature as your skin, when there is no breeze, no sound of leaves, just the weight of air. It's perfectly matched to your presence. It is a strange, almost eerie feeling, like floating in time. Nothing pushes, nothing pulls, and in those moments, the sky feels not like a force, but like a room, a place you inhabit fully, without tension. Such days are rare, but unforgettable, because they remind us we are not merely standing under the weather. We are inside it. We are breathing its breath. We are made of its molecules. And long after we are gone, the weather will continue. Clouds will still form. Winds will still spin. The sun will still warm one side of the earth while the other cools. And in that ongoing rhythm, Carrie, there is something deeply comforting. Because no matter what else changes technology, society, even the land itself, the air still moves. The sky still turns. The weather still speaks, softly, constantly, if only we are quiet enough to hear it. If only we are quiet enough to hear it. ... The whisper of the sky is not always carried by wind. Sometimes it arrives in stillness, in scent, in pressure, in the slow shifting of shadows on stone, okay? And sometimes that whisper becomes aurora. Reminder that even something as soft as air can carry immense power when gathered and focused. Among the most compelling expressions of this power are storms. They arrive in many forms, small and local, large and planetary. But the physics behind them is always a negotiation between heat, pressure, and moisture. A storm begins when imbalance occurs. The air becomes too warm in one place, too heavy in another, too moist in one pocket, too dry in another. Nature does, not like imbalance. So the atmosphere begins to move, redistributing energy. Consider the thunderstorms so common, okay? And yet so majestic. It often begins with surface heating. A patch of land warms under the sun, heating the air above it. That air rises, carrying moisture with it. As it climbs higher into the troposphere, it cools, and the moisture condenses into cloud droplets. This condensation releases latent heat, a hidden form of energy stored in water vapor. This heat warms the surrounding air, making it rise even faster. Updrafts become stronger. Clouds grow taller. Eventually, the system matures into a towering cumulonimbus, the cloud that produces thunder, lightning, and heavy rain. Within this cloud, tiny particles collide, crystals, water droplets, hailstones. These collisions separate electrical charges. Positive charges accumulate at the top of the cloud, negatives near the base. The ground beneath becomes positively charged in response. When the difference becomes too great to contain, the air breaks down, okay? A path of ionized air forms a lightning bolt connecting sky and earth in a brief, bright exchange. The sound that follows, thunder, is the shock wave of superheated air expanding rapidly along the lightning's path. Light travels faster than sound, so we see the flash first, then count the seconds until the rumble. Each second roughly equals a third of a kilometer in distance. There is something ancient about this equation. Children count seconds. Sailors once did the same. So did shepherds on open plains, farmers in mountain valleys, nomads under desert skies. Because storms speak a language older than science. They are felt in the bones, heard in the gut, read in the tension of the wind and the stiffness of tree branches. But storms are not just local spectacles. Some span thousands of miles. Cyclones, hurricanes, phones different names for the same phenomenon, depending on region, are born over warm oceans, where evaporation feeds the sky with moisture and energy. If conditions are right, low vertical wind shear, sufficient Coriolis effect, and warm sea surface temperatures, a low pressure system may begin to rotate. Air spirals inward toward the low pressure center. As it does, it rises, cools, condenses, and releases more heat, fueling further ascent. A self-sustaining engine of heat and motion begins. At the center of the storm, where the air is descending, lies the eye, eerily calm, clear, and bright, while devastation spins around it. These storms can last for days. They can reshape coastlines, carve new river paths, strip forests bare, and yet they follow a simple rule. Energy must move. Heat must rise. Balance must be restored. Even in their violence, there is order. Even in their destruction, there is pattern. But not all storms are wet. Some are built from dust, sand, and air alone. In arid regions, when hot, dry winds blow across loose soil, the land itself begins to rise. Billions of tiny particles lifted into the air, forming dust storms or haboobs, walls of dust that can stretch for miles, obscure sunlight, choke machinery, and reshape entire landscapes. They are ancient phenomena. There are Mesopotamian tablets describing dust storms that blotted out the sun. Egyptian tombs show farmers shielding their eyes as wine-borne sand whipped across the Nile. Even Mars, with its thin atmosphere, hosts planet-wide dust storms that can last for weeks. These movements of particles, though dry, are also a part of weather, because weather is not just moisture, it is motion, it is contrast, it is flow. And in the most extreme environments, at the poles, atop the highest peaks, in the heart of deserts, weather is defined more by what is absent than what is present. But even absence creates form. A lack of humidity changes sound. A lack of clouds deepens sunlight. A lack of wind brings eerie silence. And then there are places where weather collides in complex, overlapping ways. The monsoon, for example, is not a single storm, but a seasonal reversal of winds, driven by the contrast between land and ocean temperatures. In India, the monsoon brings months of rain-nourishing crops, filling rivers, greening hillsides. But it also brings floods, landslides, and disruption. In the Sahel region of Africa, the monsoon is a lifeline. Its late arrival or early retreat can mean famine, and in Southeast Asia, the monsoon defines calendars, ceremonies, harvests, and even architecture. Roofs are sloped steeply to shed rain. Homes are built on stilts. Markets are timed around. CLOUDBURSTS. Weather is not just background, here it is calendar, map, and measure. And in the far north, another weather story unfolds, one that is less wet, but no less profound. Polar vortex. A term once limited to meteorological textbooks, it has now entered common language. It refers to the large-scale cyclonic circulation of cold air around the poles. In winter, this vortex tightens and strengthens, containing the cold within its spiral. But when it weakens due to warming waves in the jet stream, or other factors, it can wobble, stretch, split. When this happens, lobes of cold air descend into mid-latitudes, bringing frigid temperatures to places unaccustomed to such extremes. These events remind us the atmosphere is a single system. What happens at the poles can change the weather in Paris, Tokyo, New York, Karachi. No region is isolated. And though we often talk about bad weather and good weather, the truth is weather is neither kind nor cruel. It is indifferent, but in its indifference, there is honesty, a kind of reliable unpredictability. It does not hide its motives. It reveals its plans and pressure gradients, satellite loops, cloud types, and wind direction. We just have to learn to read the signs. And in that reading, there is an intimacy, the kind that comes from noticing the shape of shadows just before dusk, from feeling the texture of air shift before rain, from smelling ozone in the minutes after lightning, from seeing birds fly low, signaling pressure drop. These are not outdated skills. They are sensory fluency, and they connect us to something older than technology. Because before we were citizens, as travelers, scientists, or merchants, we were all just people beneath the sky, trying to understand what tomorrow might bring. And in that way, we still are, still tracing the shapes of clouds with our eyes, still wondering if the wind needs change, still watching the horizon for movement, still sleeping beneath an atmosphere that watches back not with eyes, but with motion. Tonight, as you rest, the wind continues, high above. Cold fronts and warm fronts collide and swirl. Moisture, CONDENSES. Clouds breathe. Pressure shifts. Somewhere, thunder rolls. Somewhere else, snow falls in silence. And over all of it, the same thin blanket of air turning softly with the earth. The weather is still working, even now, even here, even as you begin to drift. Even as you begin to drift, the atmosphere continues its quiet choreography. Patterns spiral across oceans. Breezes slip through narrow valleys. Clouds pass silently over sleeping cities. Somewhere, in a forgotten field, a single blade of grass bends under Duladon, Aaron, unnoticed act. It's still a part of the weather's vast expression. This is the nature of atmosphere. Its scale is planetary, yet its presence is personal. It touches every skin, every surface, without discrimination or pause. There is no object or organism it does not encounter. It brushes the tops of trees and the cheeks of children. It rattles windows and lifts pollen. It presses against aircraft wings and finds its way through cracked doors in the dead of night. And yet, rarely think of it as a substance. We often speak of the air as if it is nothing, as if it is simply what fills the space between objects. But the air is not empty. It is weighty, full, complex. It is a mixture of nitrogen, oxygen, argon, carbon dioxide, and traces of other gases. Sea, salt, soot, pollen. It carries scents, spores, and sound itself. And it changes constantly. Humidity, for example, is not just a measure of water vapor. It is the difference between a morning that feels crisp and one that feels heavy. It influences how fast sweat evaporates, how food spoils, how machinery functions, how plants breathe. In fact, the leaves of trees are quietly negotiating with the weather at all times through small pores called stomata. Plants take in carbon dioxide for photosynthesis, but they also lose water through transpiration on hot or dry days. Many plants close these pores to preserve moisture, sacrificing growth for survival. This balance between atmosphere and life plays out millions of times per second across every leaf and blade of grass, forming what scientists call the biosphere exchange. It's not just a poetic phrase, it's a literal, measurable flow of gases between the earth and sky. The air is not simply around us, it is part of us. With each breath, we take in molecules of oxygen that may have been exhaled by a forest half a world away, or released from melting sea ice, or stirred up by a typhoon, or passed through the lungs of someone long gone. And as we exhale, we give back carbon dioxide and water vapor molecules that will eventually rise, cool, condense, and fall again. Each of us is part of the weather's cycle. Even our bodies reflect this rhythm. Our skin senses pressure drops before a storm. Our joints ache with cold fronts. Our sleep patterns shift with barometric fluctuations. And deep in our biology, circadian rhythms, those invisible clocks that govern waking and rest, are influenced by the timing and quality of daylight, which itself depends on the atmosphere. On cloudy days, melatonin stays longer in the bloodstream. Bright mornings, cortisol rises faster. These hormonal dances are not abstract. They are directed by the sky. But the sky is changing. In the last century, we have altered the atmosphere in ways no generation before us has. Carbon dioxide levels have risen sharply. Methane, nitrous oxide, and other greenhouse gases have accumulated. Aerosols from industry, agriculture, and combustion linger in the lower layers of the atmosphere, altering its reflectivity and absorption. And the result is not just warming, but shifting. Patterns of rain have changed. Storms are more intense. Droughts last longer. Freezes arrive later, or not at all. Even jet streams, those high-altitude rivers of air that guide storms, have begun to meander more widely, lingering longer over regions and causing prolonged heat waves or floods. This is not just a change in numbers. It is a change in behavior, and behavior is how we experience weather. A temperature graph means little when compared to a delayed monsoon, a failed harvest, a flooded home. For many, the weather has already changed, not in theory, but in reality. Fishermen, notice the winds are different. Elders say the rains no longer follow the old calendar dots. Snow comes late. Bird migrations shift. The air carries a new mood. But even as we acknowledge these shifts, the weather continues to teach us. It reminds us that nothing is permanent, even the patterns we once trusted. It shows us how the smallest balance can grow into vast movement, and it reveals, gently but persistently, that everything is connected. A wildfire in one hemisphere can darken skies in another. A change in ocean temperature can redirect winds across continents. The melting of permafrost releases ancient gases. The loss of forest cover changes rainfall miles away. And yet, the atmosphere responds with the same tools it always has: motion, temperature, moisture, balance. It is not cruel or kind. It is simply responsive. It follows the physics of fluids, the chemistry of particles, the gravity of the earth, and the push of the sun. Nothing more and nothing less. This humility, this lack of malice, makes it all the more powerful, because it means that the weather does not need to choose. It acts, it flows, it continues, and in that continuity, there is something deeply comforting, no matter how much changes. The rain still falls in drops. The wind still hums through branches. The snow still gathers on silent fields, and the sun, whether seen or not, still warms the side of the earth turned toward it. There is elegance in this repetition, a kind of planetary heartbeat. We measure it in degrees, in millibars, in kilometers per hour. But it can also be felt in more human ways, in the way a child presses their hand to a cold window, tracing raindrops, in the way a farmer looks to the sky and silently guesses how long the dry spell will last, in the way a city quiets just before a summer thunderstorm, windows closed, traffic slowing, air holding its breath. These are the rituals of living with weather, and they are not new. On every continent, in every era, people have watched the sky. They have told stories to explain it, made calendars to follow it, built tools to measure it, formed prayers to influence it. And though our tools have changed from sundials to satellites, the attention has remained constant, because the sky holds our stories. It holds our past and our future. It holds the signs. Still don't fully understand why some clouds twist while others spread, why one gust becomes a gale and another fades, why rain sometimes carries the scent of metal or dust or memory. These are questions science continues to explore, and yet not all understanding needs solving. Some things are meant to be watched, not solved, not controlled, just witnessed, like the slow curl of morning fog over water, or the moment sunlight pierces a gray sky in a single shaft, or the hush that falls before hail. These are not facts, they are moments, and the weather, more than anything, is made of moments. It is the texture of life between events, the pause, the breath, the background music of the earth. Even now, as you rest, it continues its quiet song. Far above, the wind turns gently in upper layers. Near the surface, warm air rises, cooler air sinks. A soft pressure gradient slides across a plain. The clouds gather, dissolve, reform. Everything is in motion, but none of it hurried, because weather, like sleep, follows no clock. It moves at the pace of the earth itself, turning, breathing, unfolding. Let that rhythm carry you now. Let the weight of the day fall away. The atmosphere will keep watch. The atmosphere will keep watch. It always has, from the earliest days of the planet's formation. Before there were trees or rivers or eyes to behold it, the air encircled the earth like a patient veil. In its earliest form, the sky was thick with volcanic gases, carbon dioxide, sulfur, methane. It was unbreathable, alien, yet even then it was weathering, moving, shaping, over time, with the cooling of the earth and the arrival of water, first in vapor. Then, in oceans, the air began to change. It learned to hold moisture. It learned to rain, and with rain came erosion, rivers, lakes, and eventually life. First, simple live cyanobacteria and algae. They performed a miracle without knowing it. Photosynthesis. They pulled carbon dioxide from the air and exhaled oxygen. Over eons, this single process transformed the planet's sky from toxic to breathable, from hostile to home. Every lungful of air we now take is part of that legacy. It is not just a substance, it is inheritance. Even now, the oxygen in the atmosphere remains at just the right balance for life, not too much to ignite with every spark, not too little to suffocate the breath. A balance struck through millions of years of quiet trial and natural memory. And so, when we speak of weather, we are not simply referring to today's forecast or tomorrow's drizzle. We are speaking of a long, continuous process, one that predates language, one that shaped the continents and the creatures alike, one that will outlast cities, maps, and names, and yet we live within it, intimately. Even the most solid things, we know mountains, a stone, architecture, slowly being softened by weather. The constant cycle of freeze and thaw, rain and wind, heat and cold. Every pebble was once part of a cliff. Every grain of sand once part of something. Massive dot weather is the great sculptor, and it is also the great connector, because it moves, it travels, it links places. Dust storm in the Sahara can fertilize the Amazon rainforest with ancient minerals. Carried across the Atlantic, a typhoon in the Pacific can affect ocean temperatures that eventually shift rainfall patterns in Europe. The breath exhaled in one place, months later, may rise with air currents in another. It is humbling to realize that we are never really isolated. The air we inhale has passed over forests and oceans and cities. It has circled mountains, flowed through valleys, risen with fire, fallen with rain. In a way, to breathe is to participate in the story of the planet. Even in sleep, this continues. As you rest now, your breathing is slow, gentle, and outside, beyond the walls of your room, the atmosphere does not sleep. It flows around structures and trees. It gathers moisture from leaves. It traces the heat escaping rooftops. It drifts silently down streets, across fields, over oceans. The boundary layer, the lowest part of the atmosphere, just above the ground, is where this intimacy lives. It is where our bodies, our breath, our fires, our machines all release heat and moisture into the sky. This is the layer where fog forms, where dew settles, where insects hover above it. The troposphere contains nearly all the weather we know. Its upper edge, the tropopause, is not fixed. It rises and falls depending on latitude and season. Above that, the stratosphere begins home to the ozone layer, to jet aircraft, to calmer, thinner air. Each layer above is colder, then warmer again, then colder once more. A rhythm of temperature that reflects the layered history of the planet. But temperature alone is not what we feel. We feel wind chill, humidity, pressure. The same 10 degrees can feel sharp or soft depending on the shape of the wind, on the moisture in the air, on the thickness of our clothes. Weather is not just numbers. It is sensation, and sensations are memory. A breeze from the south may remind one of spring, the first scent of petrichorus, after rain may pull an entire childhood from the shadows. A cold morning, with frost along the windowpane, may carry echoes of hands once pressed against glass. Watching the fog of breath disappear in this way. Weather is personal. It follows us across years. It bookmarks our days. We remember weddings that were rained on, afternoons turned golden by low autumn sun. The exact moment lightning struck too close. The stillness before a storm. The warmth of stepping into shelter from snow. These small memories become part of our internal, our own emotional barometer. And yet, the atmosphere is impartial. It does not know we are here, but we, in turn, are always responding to it, adjusting, adapting, forecasting. The word forecast itself comes from Old English meaning to foresee, and humans have always tried to do just that. From reading animal behavior to watching cloud shapes, to building mathematical models powered by supercomputers. Today, weather forecasting is a blend of observation, satellite imagery, radar, physics-based modeling, and pattern recognition. And yet, with all our tools, there is still a margin of uncertainty. A small shift in moisture, a fraction of a degree, sudden ripple in the jet stream. These can change the outcome, because the atmosphere is a chaotic system sensitive to initial conditions. This is why weather models are run in ensembles, dozens or even hundreds of simulations, cute, slightly different, to show a range of possible outcomes. And so we predict not with certainty, but with probability. It is a science of gentle humility, a recognition that nature, while governed by laws, is not always predictable in practice. But perhaps that is part of its comfort, because weather, like life, is full of variance, of patterns and surprises, of calm spells and turbulence, of long, quiet stretches and sudden changes. And in this unpredictability, there is room to rest, to surrender, to let go of control, because the atmosphere does not need us to understand it fully. It simply needs space to move, and we, in return, are granted breath. Even now, as your body grows heavier, your breath slower, the air continues its quiet watch. A wind in the upper troposphere travels eastward at high speed. A small thermal rises from a patch of warm ground. Clouds gather silently over a distant forest. A cold front inches toward a sleeping coastline. And through it all, the atmosphere remains thin, clear, invisibly, yet always there, moving, shaping, breathing, the same air that carried the wings of migrating birds, that flowed over ancient pyramids, that rustled the pages of forgotten books, is here now with you, in this room. It does not demand attention. It simply is. Let it wrap around you like a soft blanket of motion. Let the pressure of the day dissolve into stillness. Let the world beyond your window continue turning quietly and faithfully. The weather will do what it always has observed. Just drift and carry on. And you, too, may simply rest within it, without expectation, without urgency, only breath, only stillness, only sleep. Good night.